Hello and welcome to the Edupedia world. Well, in this tutorial we'll cover the part 3 of exception handling in Java. In this tutorial again we'll be covering up an important topic of exception handling. So let's do that. So the important topic we are going to see over here is propagating uncaught exception, or we can also say that as exception chaining. So we'll see what is that. Okay. Most languages have a concept of method stack or call stack. Simply put, the call stack is a chain of methods that your program executes to get to the current method. If your program starts in a method main and main calls a method A, which calls a method B, which in turn calls a method C, the call stack consists of the following, which will be C will be on the top, then B, A, and finally the main. So the method that calls first will be on the bottom. We represent the stack as growing upward, although it can be visualized as growing downward, but stack is considered as growing upward. As you can see, the last method called is at the top of the stack. While the first calling method is at bottom, the method at the very top of the stack trace would be the method you were currently executing. If we move back down to the call stack, we are moving from current method to previous called method. So this is how it is done. You can see there is an example in which we are having a call stack. Let's say we are having main method 1, 2 and 3. So the call stack while method 3 is running would be like this, where the first thing that we would have is method 3. So method 3 is something that method 2 has invoked. Then if we go downwards, that is on the third index, there would be method 2. And method 2 is invoked by method 1. On the second index, we will have method 1. And finally, on the first index, we will have the main method that begins calling the method 1. Okay. So this is the order in which methods are put into the call stack. Now, what will be the call stack after method 3 has completed its execution? Well, method 3 will be removed, and this will be the execution. So you see over here on the index 1 now we are having method 2. Okay, method 2 will complete. After that method 1 will complete, and after that main will complete. So this is the order in which they will complete. Okay. Now let's examine what happens to the ducked exception. Let's say a ducked exception are those exceptions which are not caught in a same method. Let's say in our previous example, let's say method 3 throws a exception and method 3 is not having a try catch clause. Then what will happen? Okay. Imagine a building say 5 stories high and each floor there is a deck or balcony. Now imagine that on each deck one person is standing holding a baseball mitt. Okay. Exceptions are like ball dropped from person to person starting from the roof. An exception is first thrown from the top of stack, in other words the person on the roof. If it isn't caught by the same person who threw it, the person on the roof, it drops down to the call stack to the previous method, which over here in our example is, which is a person standing on the deck one floor down. If it is not caught there, then the person on a floor down, the exception ball again drops down to the previous method. Okay, that means person on the second next floor. And so on until it is caught or until it reaches the very bottom of the call stack. This is called exception propagation. If an exception reaches the bottom of the call stack, it's like reaching the bottom of very long drop. The ball explodes and so does your program. Okay. An exception that never caught will cause your application to stop running. A description, if one is available of an exception, will be displayed and the call stack will be dumped. This helps you debug your application by telling you what exception was thrown, from what method it was thrown, and what the stack looked like at a time. Fine. So propagating an exception means not handling the exception in the same method and passing it to the method that called it. Okay guys, let's quickly do a demo of a method or exception propagation. So over here I'm creating a class. exception propagation demo, and let me have a main method inside it. Okay. Now let me create the object of this class over here. Fine. Now let me have some methods in this class. So the first method that I would like to have is public void. Before calling a method, let's take a live scenario. Okay, let me do something. Let me first actually take 5 numbers and add them. Now divide sum by 5 to calculate average. Okay. After that, add 3 to the average, or I would say add 0.3 to the average. Okay. So I am adding 3 just to keep it as integer for simplicity. Otherwise, the need that I am adding is for, to just do a precision check. Let's say if my average, I do know that there's a precision error of 0.3, then I'll add 0.3. But over here, just to keep it as simplified and not to take a float and take every integer, so that's why I'm adding 3 to the average. Okay. So we have to do this. So one thing is we can do everything in one method. But what if I wanted different methods, and I should create different method because every method should perform a different task. So let me create 3 methods to do these 3 things, because it could be possible that at some point of time I would only want to do a sum and not calculate an average, or at other particular time I just wanted a average without the precision, and at some point of the time I wanted, or at other point of time I might need the average after correcting the precision error. So let's create 3 methods. So first method I am doing is public void sum, and let me introduce parameters as 5 variables to it. Fine. Now let me just add these variables. Okay. Let me put a try catch over here. So the try catch that I am putting over here is adding. So I am taking int sum equals to a plus b plus c plus d and plus e. Fine. And after that, let me return it. Firstly, let me show you this without a try catch. Let me not put a try catch over here, and let me simply just return it. So I'm returning sum. To return the sum, I need to change the return type to int. Fine. So I've created my sub method. Now let me create the 2 other methods also. The other method that I'm creating is public int average evj, and I'm giving it as parameter as sum, and I'm doing average, or rather int average is equal to sum divided by 5. Okay, and then return average. Fine. The third method I need to create is to correct the precision to it. Therefore, I'm making int precise, and I'm doing int average, then return average plus 3. Fine, but what I need to do is, instead of returning from each and every statement, let me just return from the last statement and call the method one from each other, because here we are trying to do is a exception propagation. To show you the propagation, let me call the average method from sum. So instead of returning sum from here, let me just call the average and pass sum as a parameter to it. So if I do that, let me change the return type back to void. Same goes with it. Let me change the return type to void, and let me simply call precise method over here. So now you can see some method is calling my average method, and my average method is calling my precise method. Fine. And my precise method is simply returning average plus 3. Now, if I just try to run it, what will happen is I need to actually call first of all this sum method from my main method. So let me just call it before running it, because to see some output, I need to at least call it. Okay, let me pass 1, 2, 3, 4, 5. And since I want to print the result as well, let me change it to void and let me do printing of this over here itself. So you see, now I'm not returning anything, I'm simply doing the printing of it. Now when I just run it, it will give me the result as 6 by taking out the sum, then doing the average and then adding it to the 3. Okay. Now this is a simple case. Now let us try to throw some exception to it. How can we throw an exception to it? Let me just do it like int precise. This is actually giving me a compile time error. What I wanted is to have a runtime error. Okay. So since this is a very simple program, so let me explicitly throw an exception, because this is not giving me any error as such. Or if your program just give an exception, you can just do nothing, but it will automatically give you an exception. But if it is something that is not giving you exception, so that's why I'm like explicitly calling the exception. So see, when I did throw new exception, it's asking me add throws declaration or surround with try catch. Now let me just add throws declaration. So if I just throw this declaration, this will start giving me an error. Why so? Because I'm calling this method over here and the method which is calling it is not handling it. So I need to handle it. So again I have to add throws over here. Now since I added throws over here, so the method that is calling average, that is sum, will also give me an error, and we need to add again throws over here. So when I did this again, when I'm calling sum over here, it is also giving me an error. Let me also do throws over here. Okay. Now let me just run this program. So now if I run this program, you see firstly the output is printed and then some the method is shown, and since I haven't properly handled it, so it's just printing all the stack trace over here. To properly handle it, finally in the method that is calling the first method, I should rather add a proper try catch so that I can do whatever I wanted to do in the method. Okay. So I might want to, like, let's say print something. So I might want to print my user defined message. Over here I'm just printing this is a catch, but in a real application you might want to print some user defined error, because in this case that exception could occur, so you might throw an exception. So see, whatever I have written in the catch block, it is printed, and the stack trace is also printed since I'm printing the stack trace. If I just remove this, it will not print any stack trace in the console. It will simply print this is catch. So this is how the exception propagation happens, and it is always done in a case of runtime exception. And whenever it is done, you should make sure that you're properly handling it, because if you do not handle it properly, then your application might halt abnormally. So you should properly handle your exception, and each method that is propagating exception should use throws clause to throw an exception. So this is how we do exception propagation in Java. Fine. Okay guys, thank you very much. In this tutorial we have seen how to do exception propagation and have also seen an example for the same. Let's meet in the next part of exception handling tutorial. Thank you.